El doctor nos va a presentar la conferencia Monitoreo pasivo acústico de, de la alimentación, es- escuchando bajo el agua, se llama la conferencia. Es Passive Acoustic Monitoring, Listening Underwater. Doctor, adelante, por favor.
Thank you very much. I would like to let you know it's very nice to be here and actually in person. It's great to be back here in Mexico where it's nice and warm and very good food. Presentation I'll do today is lots of information from a lot of different people. I have lots of students and faculty who helped me with this research. I do want to recognize Silvio Proxo, who's in Brazil. He's the one who's responsible for crunching all the acoustic things. He was in my lab for about 2 years, and we've had a great deal of collaboration together. So, kind of my first question is, why listen? That's what my wife says to me all the time. Why aren't you listening to me? If we know how to interpret it, we might be able to use it for our benefit and to increase our ability to make money. So, passive acoustic monitoring, or PAM for short, is simply listening underwater. So passive acoustics is where we simply use a microphone to listen, whereas active is like you send out a ping and receive that again. And so this is a very non-invasive approach using a hydrophone. So it's simply taking a microphone and putting it in the water and then listening to noises that come through. That data can be recorded, or you can listen to it directly and you can actually analyze it. We're familiar with, for example, whale songs, right? A lot of people have heard those beautiful noises that the whales make to communicate. Well, our crustaceans also make a lot of different noises that we can use to communicate. And we'll see if this will go forward. Go ahead and play it. So this is a timed video, and you may have seen this. And if it doesn't play, it's no big deal. But you can see the mandibles coming together, and then up in the right-hand corner, there's actually a click. And so if it doesn't run, it's no big deal. But you can see that when those mandibles come together, or it's like our teeth coming together, there's a very distinctive click that is made, and that's associated with feeding. And so using passive acoustics, we can listen to what that shrimp noise is making. And we actually have some software out there, and the software that we use is Raven software. It's actually designed for use of birds and interpreting their songs that they sing and identifying the birds. But you can use this software to record and analyze the noise that the shrimp is making. So for example, we can look at the number of clicks per minute, and we can look at the parameters of that particular noise. And so this is an example of actual click and the data that you can get on it. And what you can see is that that click goes over a very wide range of frequencies. And at each of the frequencies, you get a different amount of energy. But since it is a fairly wide range of energy or frequency, we can also filter out some frequencies that might be causing problems. So you can go in using this software and actually filter out areas if there's some interference that's occurring. But we can get a lot of information by listening to the shrimp. And so this is an example of outputs in terms of looking at feeding activity in the laboratory. So we can not only get that big range, but if we also have interferences, we can filter them out. But you can see here is an example of all these clicks that are being made by the feeding activity, and then you can see that in a variety of graphic forms. So we can go in and actually analyze this data on a real-time basis. And to me, the acoustics has a lot of different applications or things that will affect it. And if we're going to use this as a tool to manage our systems, then we need to understand each one of the components and how it affects our recordings or our listening to the shrimp. So from the feed standpoint, the different processing technologies, grinding, extruding, pelleting, these all affect the hardness of that pellet or the shear of that. So how much energy does it take to break that? It's kind of like if I give you a gummy bear or I give you a jawbreaker, it's going to take a lot more energy to break through that hard jawbreaker, that candy, than it is this soft candy. So it makes different noises. Also, when you're looking at the thickness or the length, so there's lots of factors in processing that may affect the signal that is given off, and we'd like to understand that. There's also differences between animal species, the size of the animal, of course, the numbers of animals that are around that microphone. If there's one person clapping in a room or 1,000 people clapping, it's a much different signal. But we also have environmental factors such as water temperature, or in this case of low dissolved oxygen or high levels of ammonia. All these things affect the animal and how they respond to the feed, but then also the noise that's produced from those animals. So again, if we understand what's going on, we might be able to interpret those results. And then, of course, also at the level of when we're doing this commercially, when we're attaching this to a feeder, there's a lot of things about the feeder and the stocking densities that affect the signal that's given back to the software that's trying to interpret what's going on. So for example, the feeding area. So you think about it, when you have a feeder that only throws in the same amount of feed in a small area versus a large area, you're concentrating the shrimp in a smaller area, but you're also limiting feed into a smaller area. So the area that the feed is distributed, the density that those shrimp are when they come into that feeding area, the spin rate, how often does it go out, the speed that it spins, which determines how far it's thrown to give a different diameter, the weight of the actual pellet, how far it goes because of that weight. So there's lots of different things that affect it on the commercial side as well. And our goal is to try and understand a lot of this and trying to give interpretation of what's going on. So I want to take you through at least what we know from our laboratory work and some observations in the field with the interpretation of acoustics. So I want to start off in the laboratory where we're using it as a very nice research tool. And so the nice thing about it is it works across different systems. So we've used it in small aquarium, big tanks, basically any system, as long as there's not a huge amount of noise interfering with that signal, you can use it. We do have certain things that we'll do to minimize interferences. We've done this in aquariums where there's absolutely nothing done, but if you want a clean signal, there's some simple things that we often do is we'll put a soundproof lid on the top. We might turn the aeration off or the water flow off just to quiet things down a little bit. But basically, we can do this in the middle of a growth trial. So it's a really nice tool. These recordings are then kept, and then you can analyze them depending on what you want to do. So just take you through a little bit of the data that we've looked at in terms of things that we're trying to understand with the feed. So we got the same formulation, both as a pelleted and extruded, just to see if there was any differences. What we think the best tool for looking at the amount of noise that's produced from a pellet potentially is using a texture analyzer. We've got some very good correlations with the texture analyzer to the noise that's being produced. Now, density of a pellet probably is a good proxy for that, but we have not looked at a correlation between the pellet density yet and the texture analyzer results. And there are issues with using the texture analyzer, so it may not be the best answer. But we did look at that in terms of a pelleted and extruded feed early on in our research. And just to show you, this is a 30-minute recording, and we see a pelleted feed and extruded feed. And I'm not saying that one gives different signal because, different formulations and different changes in any technology are going to give a difference in the signal. Just showing that you can pick up differences between different feeds. But also I want to point out, this is a 30-minute recording. This is the energy that's being produced at any time during it. And you can see that it's very high energy input when you first put the feed in there, and then that energy input comes down, okay? And you'll see this in a lot of our data in terms of what's going on. So we wanted to, again, look at the the effects potentially on the signal. So we also took a standard 2.4 diameter pellet and we got it in different cuts. So realize you can, produce a pellet or extrude a pellet at different size diameters, but you can also cut it differently. So this was a small, a medium, and a large, and we wanted to look at the signal and other things. So we did use some specialized equipment for that, but for the most part, data is coming out of an aquarium trial. So looking at the frequency, we wanted to see if the length of the cut made any difference in the signal, and it doesn't. And that's what you would expect. Absolutely no differences there. But then when we look at the number of clicks, we find that there were differences. And so the graphic here has the 3 different sizes and the number of clicks that are being produced as time goes on. And notice we're only going to 10 minutes because that's where a lot of the activity is. But essentially, a short pellet had less clicks than a medium pellet or a long pellet. And that makes sense because basically they're biting through the kibble. So if it's a short kibble, there's fewer bites. If it's a long kibble, it's going to be more bites, right? But what's interesting is that they actually came down much quicker with the smaller pellets in terms of going from high energy to low energy. So they're eating it actually a little bit quicker than they are the longer pellets. So we can also look at the energy from this feeding activity. So again, this is the same 3 different sizes. I'm just showing you 5-minute intervals in the bar graph. And so we go all the way out to 30 minutes. And then I've got a regression, general falling off during that first 15 minutes is really where the action's happening. But as you can see, the smaller pellet is falling off much quicker. And what we think that is they're basically just popping the small pellets in their mouth a lot faster than they grab a big pellet. Now, don't take this to the bank and say, I need the smallest pellet I can find, because they also have to find the pellet. So remember, this is just them consuming it. If you have to go out and pick up grains of rice, yeah, you're going to eat them a lot faster than you would a big, apple or something. You got to take bites out of. But that doesn't mean it's efficient for you in terms of going out and getting feed to go grab rice. It's more efficient for you to grab something that's larger. So realize there's 2 sides to this, how fast something is eaten and how easy it is to capture. We're just looking at consumption. So again, showing that small, medium, and large, and the fact that you see a lot flatter line when you're talking about the larger. That's the energy, total energy that they're producing. Okay, so smaller feeds. And it doesn't cost you anything to make a shorter cut than a long cut. That's no cost at the mill. When you change the size or diameter, those are costs associated in terms of processing. So we've done a number of studies, and I'll take you through them on the feeding behavior. So this was top coating. So we took different feeds that were commercially produced, and then we top coated them with different products. So in this case, we looked at krill oil and fish hydrolysate. And so we took an all-plant diet, added fish hydrolysates to it, or we added krill oil to it. We took a poultry meal, so it's a mostly plant-based diet with about 8% poultry meal added to it. And then we added the hydrolysates to that as well as the krill oil. And then we have a reference of an 8% level of 8% fish meal in the feed formulation or 12% fish meal in the feed formulation. And again, looked at the acoustics and also looked at the consumption. And so again, showing you 2 different, the first on your left is 30-minute recording, then 15-minute recording. So I've just taken the first 15 minutes there. And what you see is that there's very different slopes to these lines. The general levels are the same in terms of the 15 versus the 30. But you can see that the 30-minute or the 15 minutes, it's a lot steeper. And that's because most of the activity is happening in that first 15 minutes. So the longer you go, the flatter that line is. But you can see there's big differences in terms of the height and also how fast they fall off. And that's due to differences in consumption. And then on the far right with the bars, you can see our 3 different diets with the different additives onto them, and that the actual consumption also was different. Now, when we measure consumption over a 30-minute period or 1-hour period, it's really actually hard to get differences because you're dealing with a relatively small amount of food and there's a lot of variation in it. What we're seeing is that the acoustics is much cleaner data, and you can see what's going on a lot easier than trying to do the actual consumption. But the consumption is there to validate what's going on with the acoustics. So that the previous one was a small animal, 4.5 grams. Did the same thing with a 13-gram animal. So this is larger animal, and it looks pretty much the same. So the response of different size animals looks to be very similar in terms of the response, different matrices, as well as different attractants that we're adding to them. So those were top-coated. So then we looked at adding some potential attractants or palatability enhancers into the diets. And so we made different feed formulations. And so in this case, we had no additions. So this is a plant-based diet. 1, 2, and 4% inclusion of either the fish hydrolysate, krill meal, or krill oil. Now, the krill oil changes a lot of nutritional parameters, so realize that there's other things changing with that, but the krill meal and the fish meal, not so much, or the fish solubles. Ran this as both a growth trial, we looked at the acoustics, and we looked at the feed intake. And there was pretty much no differences across the board for the growth trial. So again, here's the acoustics with all of our different diets, and there's a lot of diets there, but the take home is that they do have different slopes to them. In this case, this is cumulative energy over 30 minutes. And on the right-hand side, you can see the feed consumption. And so our basal diet, which is a fairly bland soy-based diet, we did increase the attractability of that diet. Now, as I said, in the growth trial over time, there was actually no differences in the laboratory for growth. So we've also, again, looking at this, taking it from the lab, then all the way out to the field. These are diets that we had commercially made. And so this will be the laboratory component, and then I'll show you field results in a little bit. But we took an all plant-based diet, so it's about 50 to 55% soy with corn protein concentrate, so there's no animal protein sources. And then we added 2% krill, we added 2% squid meal, and then we added 4% fish hydrolysates. And the reason we added 4% fish hydrolysates is to keep the level equivalent to 2, because there's about 50% water. So reasonable levels of inclusion on a dry weight basis that are the same. And then in this data set, I'm pulling an old diet, which is 12% fish meal from a year before, just as a reference. And so again, we looked at the acoustics. We can run 6 trials at the same time, so we can do 6 recordings, 6 different aquariums, 6 different treatments, so everything's on an even level. And you can see the second middle line there is the recording. And then we've taken a very small section of that recording and brought it down just so you can see that by doing this in the lab, we can actually see the individual clicks. We can actually measure how much energy or how many clicks are being produced by those animals. And we use a fair number of replication, 12, to do this. Now, in this case, we wanted to know, is there a difference between a naive, meaning they've never seen the feed? Because sometimes if you get something new, you just want to play with it, right? It's a new toy, I want to play with it. So you get a new flavor, and sometimes animals just like it because it's new. So we gave both naive, and then we also trained the shrimp for another 4 or 5 days, and then gave the feed to them again and called them non-naive. So this means they've acclimated to it, it's not new to them anymore, are they actually consuming it? And we actually get pretty similar responses for the naive and the non-naive. So that's good. That means we don't necessarily have to train the animals. They're not just coming in saying it's new, I'm going to go ahead and take it, okay? And again, what we saw was that we quantified the number of clicks, and 75% of the feeding activity was in the first 15 minutes. So for a lot of our work, we've now switched to looking at that first 15 minutes in terms of the response. But again, we've got here in terms of the feeding behavior, the number of clicks, and you can see there's differences. And you can look at in terms of number of clicks in a regression analysis also, again, showing this as a different format. But bottom line is they start off very high with their clicking, and then they come down. About 15 minutes, they're slowing down, and then by 30, 45 minutes, it's at a very slow pace in terms of consumption. So they're very fast consumers eating very early on. So when we're doing these, we also are collecting, the feed, showing one of the students doing that. and we can look at the actual consumption. So we're doing the recordings and the actual consumption at the same time, so we can correlate the real observation of feed consumption with the acoustic clicking and energy production. And so here you can see our all plant did, in terms of consumption, consume significantly less than the other three that had attractants on them. And it occurred in both of the native and the non-native animals, or naive animals. So, if you look at, in terms of the number of clicks on the left, so we got naive, non-naive, so these guys have been trained onto that feed. And then we have food consumption. You see that the responses are very well correlated, that when we see low levels of clicking, we have low levels of feed consumption. And if you put a regression to that, so again, this is showing 15 minutes and 30 minutes. All of our food consumption is done at 30 minutes. So this 15-minute recording is against 30 minutes of feed collection. But you can see that they're very good correlations. So this measurement of clicking or acoustic energy is a very good measure of what's being consumed by the animals. So because of this, bringing it into the laboratory, being able to make recordings in the lab, we've really learned a lot about how shrimp feed in terms of their feeding behavior, and we're learning about their preferences in terms of different ingredients, different ingredient matrices. Because, this is a non-invasive technology, so we can use it during a growth trial. We don't have to disturb the animals. They're doing what they do naturally. And that characteristic of the clicking is highly correlated. I mean, we've done 5, 6, 7 different trials correlating that clicking with actual food consumption. So we can look at these feed effectors, these things that are affecting both palatability as well as attraction of the animals. But remember, just because it smells good, that's an attractant. It doesn't mean they consumed it. What we want them to do is consume it quickly, and then have nutrition to grow on it, right? Consuming doesn't also mean you're going to grow. So, from the more practical standpoint, in terms of feed management, I'm a big believer of continual improvement, continually looking at our feed management and questioning whether or not we're doing it right. Acoustics gives a whole new diameter to that. Really is a nice tool to look at things. And if you think about it, in the fish industry, there's lots of different ways to observe what's going on with the fish in terms of feed management. You can visually see them on the surface. A lot of the water that we deal with in terms of fish is very clear, so we can use visual cameras within the cages or net pens or raceways, so we can visually see things that are going on. That does not work at all in terms of shrimp. If you think about it, I don't know if you can click on that picture on the left and maybe it'll go. If it doesn't, it doesn't. That's fine. But we would have seen a whole bunch of fish just coming up and grabbing feed and throwing it all over the place. That's easy to see. Can't do that with shrimp, but we can use the acoustics and we can listen to them, and it works very well. There are things that interfere on a commercial scale with that signal, but we can manage those most of the time and get around them. So, for example, some aeration will interfere with the acoustic signal. But again, there's management tools that you can get around that. So again, we're looking at this from also a practical standpoint in terms of our research ponds. So example of one of our soy-based feed formulations, poultry bibiotic meal, corn gluten meal is the primary protein sources. And we've ran a lot of these diets over the years. So I want to take you back a couple years and just remind you, we started off optimizing our hand feeding. Then we got AQ1 system at our facility, and we realized that automatic feeders had a great deal of potential. So we started optimizing automatic feeders at our facility, and we spent 3 or 4 years optimizing automatic feeders. So this data is from the end of that, where we've worked with automatic feeders for a number of years, tried to optimize them. And we've got 3 years of data that we then pulled into what we thought was this is going to be our best feed management for automatic feeders. So at this point in time, we're going to look at day, night, and then 24 hours, and we're going to run it again against the AQ1. And we've got about 5 years of data doing this. So 35 shrimp per meter is what we typically run. So again, this is what our automatic feed curve looked like, pre-programming everything for our automatic feeders. And we simply looked at day, night, and 24 hours. Same number of feedings, same quantity of feed going into those systems. And then we ran the AQ1 again as an automatic feeding system as comparison. And so, this is the data that we've seen, is that consistently the AQ1 outperformed anything that I could do with automatic feeders. And this is very good performance. We've got about 2 grams per week, but we got 2.2 with the acoustics. We got a bigger shrimp with the acoustics. Feed conversions are pretty similar. But my conclusion was, no matter what I do with management, if I use feed trays, if I pre-program, what have you, I'm always going to be managing after the response. And that maybe my response might be a half a day, maybe it might be a day, but it's going to be later. The acoustic systems are also managing after a response, but the response is every, couple minutes. It's a very quick response. And so that was the advantage that I see with acoustic systems, is that response is managed very quickly. And so they're always going to, in my opinion, outperform anything that I do with some sort of feed tray or other management where it takes me time to interpret the results. So we converted our entire facility to AQ1 system. The year before last, we ran a plant-based diet, 8% poultry, 8% fish, 12% fish. Again, the idea was to demonstrate open formulations, but also to see if the AQ1 would respond. So in the past, I programmed our feed management. Now the shrimp are making decisions on how much to consume. So we want to give them the opportunity to see if they can perform better on maybe a 12% fish meal or maybe on a plant-based feed formulation. But they make that decision. So here's our results from 2 years ago. Sorry, let me see if I can go back. And again, we got almost no differences in terms of performance. Feed conversions were a little bit higher. Growth rate, not quite so good. What we think was that our genetics are changing. We're not getting as good a performance. But again, all these diets perform very well under production situation. So last year, we wanted to look at plant-based diets and see if we could improve them using the attractants that we'd identified in the laboratory that had better acoustic signals, that they had more clicks. And so again, running our ponds at about 30 individuals per meter. We run a 90-day approximately cycle. Again, using the AQ1, letting it self-manage all the feeders, so we're no longer managing feeders. So to give you the example, it's our all-plant diet here on the left. And then we added krill meal, we added squid meal, which is very commonly used as an attractant in a lot of the industry. And then we used the fish hydrolysate that we'd have done in the laboratory, and the krill meal was also the krill meal that we'd done in the laboratory, to see if there's any response. So again, ran it through. We do have some restrictions. So we start off hand feeding. We then go to timer feeding, and then we transition into the acoustic feeding. We start acoustic feeding about 40 days after stocking. We do run a 2-week nursery, and we do have an upper limit. We have in the programming 160 kilos per day as an upper limit for the AQ1 to feed. And we do go back in and look at whether or not we hit that limit a lot. We did not, okay? But I do have an upper limit because there's a ability for our ponds to process feed. And if you go beyond that, you're going to have lots of issues in terms of water quality. We're very much pushing our system. We do have continuous DO measurements. So the AQ1 is controlling our aeration. So AQ1 does have DO monitoring, and then it also can turn on your aerage, which is what we're doing. We still check DOs and water quality manually because we want to make sure everything's working. Having eyes on a pond, to me, are very important, even though it may be automated. So we do have people going out, and also that checks to make sure your sensors are working properly. Last year, we had lots of issues. Minor issue was we had a minor hurricane come in as we were harvesting. So that caused problems with our harvest. We had, because of incredible amount of rain last year, our salinities dropped down to very low salinity. We started at about 20. We dropped down to 6. We actually did a partial water exchange because our salinity was going down so fast. We wanted to bring it back up, and then it came back down again. So we lost a couple ponds due to blue-green algae when we had low salinity levels. And then the hurricane, again, we lost some of our As we were ready to harvest, we had to leave. And so we lost some of those animals at that point in time. So in terms of just a quick picture showing on, the size of the shrimp, so these are representative shrimp, really can't see any major differences in terms of the sizes of those shrimp. So here is our data. And again, our data for the all plant diet, by random chance, we got all treatments through to harvest, whereas for krill, squid meal, and fish hydrolysates, we have a varying number of ponds. For example, for the squid meal, to harvest, we only have one pond that actually got there without having issues. All of our cast net data, of course, in terms of weights, are fine. It's just looking at our final harvest and survivals. But again, you can see that we did get an improvement in terms of feed inputs or higher levels of feed inputs in those that had acoustic or attractants to them. And our feed input was not as much for the all plant-based diet. And our production from the all plant-based diets was not quite as much as we did from the rest. Now, there's no statistical differences, but as I said, there's varying numbers of replication here. And we've also worked out in terms of costs. We did get more return on the feed investment, and this is just looking at feed costs per unit of production in terms of the size classes. It's not a true analysis. It's just a quick analysis. But we did get higher returns for having the attractants, even though those attractants do cost you money. So we, looking at our production just in terms of graphically, you can see on the right-hand side, our growth rates are pretty much on top of each other, but we did have, in the green, increasing levels of food going into the system. And then in our red, you can see our yields. And so in general, we did produce more in terms of the yields, but is that yield due, or is that feed input due to yield, or is that feed input due to acoustic signal? We think that the fish hydrolysis was creating more clicking, more activity, and that's partially due to why that feed input was there. So if you look at our feed inputs, this is the data of daily feed inputs averaged. You can see our timer feed, hand feeding, timer feeding, and then I've got the acoustic feeding there. And just looking at it, you can see that the fish hydrolysates, there's lots of days where they're feeding much higher levels than on the plant-based, krill meal and squid meal kind of being in between. And so we think that may be driven by the clicking that's going on, although it's also driven by the amount of biomass that's in there, okay? You can't separate the two. Now, we do run parallel trials. This is the data from the aquarium systems where we saw differences in consumption. So again, that consumption does seem to maybe translate out into our pond data. We do run all of our pond data as a tank-based system also. So we pump water from one of our ponds into a replicated tank system, which gives us a verification of what goes on in the ponds under standardized conditions. Now, in this case, I do choose how much food goes into the system, so it is pre-programmed. And because we're dealing with attractants or palatability enhancers, we chose to take 2 treatments because we have room for 6 replicates or 6 different treatments. And we gave them a 30% increase in feed. So we would have our normal feed programming and then an overage of 30%. So if they were going to consume extra feed to get extra growth, they had that opportunity to do so. So this is our standard confirmation for our pond work. Again, showing those diets with the krill, the squid, and the hydrolysate. And then after 9 weeks, this is our data. And you can see there's very little differences in terms of statistics, but the survival was lower in our all plant diet. That drives the feed conversion higher. But interestingly, if you look at comparisons, the krill meal, which we did a 30% overage, so if they were to eat more food, they had the potential to grow more, their feed conversion simply went down. So I don't think, the response here is due to a lack of food, because we fed at least 2 treatments and overage of food, that this is their response. And so it does look like we are getting a positive benefit in an all plant-based diet when we do add some of these attractants, and that does translate out to some of our production numbers. So again, the use of the krill, the squid, or the fish hydrolysate does seem to have a benefit. It's going to cost you more money, but it looks like you're getting that out in terms of production performance. So, from a historical perspective, we did 2 feedings for, 15 years of my career probably. where we optimized that. And we got very good performance, very good results. So if you want to optimize hand feeding, you can do that. But until you move to an automatic feeder, something that gives numerous feed management over the day, lots and lots of different feed inputs, you're not going to get the genetic potential of your shrimp. You need the multiple feedings to get that genetic potential. And we've about doubled the growth rates of our animals going from 2 feedings to automatic feeders. And then, as far as I'm concerned, the acoustic feeders give you added benefit, number one, because they respond very quickly to what the shrimp is doing, but also they're self-managing things. So I think that's the best improvement and the best investment to go with. But most certainly, you can do it with automatic feeders. And you saw graphs earlier of Ecuador's production over the last 5 years increasing. And that's really, in my opinion, that is due to their increased use of automatic feeders. Now the industry is primarily using automatic feeders or acoustic feeders, and that's really boosted their growth rates, really boosted their performance of their animals. And with shrimp, the only way to do that is to have many, many, many meals across the day, and that can really only be done effectively, at least in large ponds, with an automatic feeding system. If you're in a small intensive system, you can do that by hand, but you need the automatic feeders. So from an acoustic standpoint, we think it's a great tool in the laboratory. We're learning a lot more about feed, the response of shrimp to feed, how they consume that feed in the laboratory. It's a good tool. And then in terms of, in the field, it's a very nice tool in terms of managing your feed. A lot of us don't do a good job managing feed. The acoustic systems can do a very good job managing that feed. Now, there are things you got to learn about it. There's technology that you got to adapt to, and you got to be able to support that. But we saw reduced feed conversions, improvements in growth, and everywhere where the automatic feeders are being affected. But we still need to understand all the factors that affect getting a nice, good signal, what is affecting the shrimp in terms of coming in and consuming that feed very quickly. So it's a great opportunity to use these technologies and improve our industry. And with that, I'd like to thank everybody for taking their time to listen to my talk. Also, of course, like to thank my students who do all the work. I just get to get up here and travel and take credit for what they do. Thank you very much for your time.
¿Hay micrófonos listos? Juan Carlos, ¿hay micrófonos para las preguntas? Bien, si tenemos alguna pregunta, es momento de que la hagamos. Si alguien tiene alguna pregunta para el doctor Allen. ¿No hay preguntas aquí localmente? ¿No? Ok, ahí tenemos ya una.
Hi, Dr. Davis. Thank you for your presentation. My first question would be, how, in terms of costs, how much do those run for usually, and how many do you need per hectare?
So they can hear me. Great question. So the question was, what's the cost? The way I look at it is you have dumb timer feeders. Those are the least cost. You have smart timer feeders. A lot of times they're web enabled. I don't want to go out and change by hand what's going on a timer feeder. That's your next highest cost. And then the AQ1 is going to, or other acoustics. There's several people who are making acoustic systems are going to be the most costly. Typically, one hopper, the problem is that each hopper will feed X amount of feed or support X amount of shrimp. And so depending on who's making those hoppers, like for example, in Ecuador, on average, they're doing about 1 hopper per hectare at their densities. But it's really a quantity of feed. So you need to know how many shrimp you have, or you need to know how much quantity of feed per day you're feeding. Then you can calculate how many hoppers you need. But the AQ1, one brain will control 2 acoustics. And so with each one of those acoustics, ideally, you only have 2 hoppers. But people are taking those 2 hoppers and then what I call daisy chaining them out to another 2, so they may have 4, they may have 6. The problem with when you expand or what I call daisy chaining, you're really not getting the signal from the feeding area. You're just mimicking with the other feeders. But a lot of people are using 4 to 6 hoppers with a acoustic response. No one's got an answer if that's good or bad, but the fewer hoppers per acoustic response, the better off you are, because you're only getting the response in that feed change. And I think it depends on how many units you're buying and whatnot. I mean, we invested probably around $10,000 per 2 hoppers in a brain, so it's not cheap. Okay, most people that I've met with, I mean, the rule of thumb is you're going to get at least a 25% improvement in performance production, and so most people have paid off converting to automatic systems within a cycle or two. They've paid them off very quickly. So there's a learning curve with, installing things and whatnot. And this technologies are advancing. So there's other things that are going along with it in terms of how to automatically fill up the hoppers, things like that. But everybody that I know of, if they've been successful in implementing the technology, has paid it off pretty quickly. And so to me, that's the key. You pay off what you've invested in quickly, then it's worth investing in.
Muy bien, ¿hay alguna otra pregunta? Si no hay alguna otra pregunta, voy a buscar algunas si tengamos aquí en la audiencia. Bueno, we have a question here from the audience. Okay, Luis Alejandro Daki is making a question about what is the opportunity area over quoting shrimp feeds based on the results that you showed us today.
I'm not sure I understand the question.
What is the opportunity area over quoting shrimp? Probably.
Okay, so I think I understand. Yeah, so if I understand the question is, how big of an area can you get a recording from? And I'm not sure exactly how large that is, but you have to get your aeration if you're having issues with interference 20 or 30 meters away. So you're probably only getting a recording in somewhere between 20 to 40 meters. So it's just that area when you're not getting not picking up sounds from the whole pond. It is just an area around, so again, if you've got one feeder on the right and it feeds about 10 meters out, and you got another feeder on your left which feeds about 10 meters out, you put that recorder in there and you're getting just that area. You're not going to get it from, say, this feeder over here that's going to be about 30 meters away. You're probably not getting any signal from that. So it is a restricted area because that noise does not go that far. I think that was the question.
Thank you. Muy bien, no hay más, hay preguntas, hay mensajes de felicitación para el doctor Allen. Vamos a darle un reconocimiento, un aplauso por su presentación. Muchas gracias.